In 2018, a SaaS analytics platform auditing their ingestion pipeline discovered that approximately 8% of customer event records had been silently duplicated for 14 months. A deduplication step had stopped functioning correctly after a dependency update. The pipeline continued running without error. Events were processed, stored, and included in every customer dashboard. Customers had been making product decisions based on usage metrics inflated by nearly a tenth. No error log had captured the problem. No alert had fired. The pipeline status showed green throughout. The deduplication step was still executing. It had simply stopped doing what it was intended to do, and nothing in the system could tell the difference. That is the defining property of silent inconsistency. Not that the data is wrong, that nothing tells you it is. Silent inconsistency is the category of data failure, where incorrect data enters or persists in a system without producing any signal that it has. No rejected write, no failed query, no exception in a log. The data is stored. It is returned. It drives reports, trains models, populates dashboards, and feeds downstream systems. And it is wrong, quietly, invisibly, for however long it takes for the consequences to surface somewhere that someone notices. The reason it is silent is structural. A database stores what it receives. It validates what it has been told to validate. It enforces the constraints that have been defined for it. It has no knowledge of what the data is supposed to mean. A duplicated event record passes every type check, every schema validation, every constraint. It fails only the test that was never written. The test that says this record should not exist twice. The database cannot write that test on your behalf. It does not know the record is wrong. 3 mechanisms produce silent inconsistency most reliably. The first is processing logic that generates wrong values without violating schema rules. A transformation function produces a value. A calculation enriches a record. An aggregation step summarizes events. Any of these can produce a wrong result and write it successfully. The database sees a valid type, a valid range, a completed write. The error lives in the logic, and the database cannot see the logic. The second is constraint gaps. Schema constraints enforce the rules that have been defined. They cannot enforce rules that were never written down. A unique constraint prevents duplicates, but only if someone added it. A check constraint can enforce ranges, but only if the ranges were specified. In systems that evolve quickly, constraints lag behind the rules the data is supposed to follow. Data that should be invalid is accepted. The gap between what should be constrained and what is constrained is where silent inconsistency accumulates quietly over time. The third is degraded pipeline steps. When a pipeline step degrades, the pipeline continues to report success. The step may run more slowly, process fewer records, or apply logic that has drifted from its specification. The output still flows to the next step. The inconsistency compounds at each stage. The pipeline's health metrics show the steps completing. They do not show the steps completing correctly. 3 approaches make silent inconsistency visible. The first is data quality assertions. Write explicit checks for the properties your schema does not enforce. The order total must equal the sum of its line items. No user record should have more than 1 active session. Event counts per customer should not deviate beyond a threshold from the previous period. These are not constraints the database enforces. They are queries you run against your data on a schedule, returning rows when something is wrong. They do not prevent silent inconsistency from entering, but they give it a surface to break against. The second is distribution monitoring. Silent inconsistency often changes the statistical shape of your data before any individual record looks obviously wrong. A duplication event inflates record counts. A calculation error shifts a value distribution. A degraded transformation step changes the cardinality of a field. Track these distributions over time. Record counts per category, value distributions per column, null rates per field. This gives you a signal layer that does not depend on any individual record being visibly wrong. When a distribution changes unexpectedly, it warrants investigation. whether or not any system has raised an error. The third is cross-system reconciliation. Periodic reconciliation between systems that should agree is one of the most reliable ways to surface silent inconsistency. The pipeline output should match the source. The reporting database should match the operational database. The ledger should balance. Run these comparisons on a schedule. Alert on discrepancies. This converts a silent failure mode into a detectable one. The discrepancy may be small, it may be old, but it is now visible, which is the only state from which it can be corrected. The analytics platform traced the problem to a dependency update. The deduplication library had changed its default behavior in the new version. The interface had not changed. Nothing in the pipeline had signaled any of it. The fix was a one-line configuration update. Correcting 14 months of affected records took considerably longer. The most important change was not the fix. It was the assertion added afterward. Every day, a check compared ingested event counts against source event counts. Any deviation above 1% triggered an alert. Silent inconsistency is not a rare failure mode. It is the default state of any system with no active mechanism for detecting it. Errors announce themselves. Outages are visible. Silent inconsistency waits. It accumulates while dashboards look healthy and logs stay clean. The data flows. The system reports normal. Somewhere in the records, the numbers are wrong, and they will stay wrong until something deliberately goes looking. The system will not volunteer the information. That part is yours to build.